Here's the function. We are not changing its location. We are not scaling it any more than the original value, and the 45 multiplied to 90 degree. And also, if we don't scale it, then this is the shape it had been before. And if I do like 0, it's gonna completely disappear because it basically turns the original value to basically 0. Making it 0 basically means removing it, and it's not gonna have it. And if I comment the scaling, basically we are not scaling it, and it's gonna have its original value, which was 0.5, I believe. And as you can see, 0.5 is the exact same value as the value of 1 from scaling. So value of 1 is equivalent to the original value of the shape that we give from this vertices coordinate here. So this value is 1, and we can downscale this value by giving the value lower than 1, and we can upscale this value by giving value higher than 1. So that's what scaling does, if you're wondering. So if we do like 0.5, then we're gonna have half of the 0.5. So we're gonna have 0.5 of 0.5, this 0.5. So we're gonna have the original value half of it. We're gonna make the original value half. So the value we're gonna get out of it is gonna be 0.25. So it should be smaller than the original coordinate value, which you can see it is. The original value was this much, and using uniform we successfully made it half smaller, which is, as you can see, this. If we turn 1, make it 1.0, and here 1.0, then it's gonna be the size of original value, which is 0.5. And here, instead of 45 90 degree, I'm gonna do it like 0 degree, because I don't wanna rotate this thing anymore. I just want to keep the original orientation and on the z-axis. And this is the same thing as before, as you can see. Nothing special, nothing's new. And if this is hard to notice any difference, if this is making any harder to notice the difference, then we can do one thing that would make this image or texture or the shape, whatever you call it, full screen, and have it cover the entire window, so we can like actually notice some difference. So let's do that here. Make it 0.5 here to, well, I don't know how it selects that, but it doesn't matter. We can just do this 0.5 with value 1.0, and we don't need to do this one. Leave that one alone. And where is the value? There it is. So we're gonna have where is the translate and scale. I'm gonna just comment the scale, so you can see it's actually covering the entire window. Come on. So that is, it's covering the entire window. And now if I'm gonna uncomment this, it's gonna covering the exact same value, because we have the value 1. The scale we have it set to 1. Giving z any kind of value would not make any difference, since this is a 2D plane. It just have x and y, it doesn't have z. So whatever value I will give to z, it literally would not make any kind of difference. It should not make any difference. As you can see, if I give 2 here, the scaling, it technically shouldn't really make a difference since it's a 2D, but since it's a 2D, but if we have like 3D plane, then it would make very big difference, because OpenGL renders everything in 3D plane, and 3D plane in 3D plane, if we render 3D objects, then it's gonna like change the width, I guess, if you call that width, height, and this Z axis, the thickness, I guess, thickness of the whatever shape you are 3D shape find would literally increase. So it will go like a bit longer in the front. So that's that. And with one, as you just saw, it covers the entire screen. And to make it smaller, we just do from 0.0 to 0.5, and we have half of that. And half of that. And we are not going to be rotating this. We can make it smaller, like 0.001. It's very small, as you may know. And very small, as you can see. We cannot see anything at all. It's way too small. Okay, so where was it? Instead of 0.01, we're going to have 0.1, which is also very small. But we should be able to see 0.1. Yeah, as you can see, we can see 0.1. 0.01 get rounded down to 0, so it becomes basically 0. And that's why we cannot see it. And we can make it bigger by giving the value higher than 1.0, like 2.0, and making it literally twice as big. And we have it twice as big. We can only see the center pixel because we literally made it too big. We can make it even bigger by turning 2 to 4, or maybe even 5. And by making 5, we literally made it 5 times bigger than the original size. And we have like this thing in the very center. We can make it like more bigger, like 10 times. Let's do that. 10 times bigger. And we can see the pixels now. We can go even deeper. We can make even more bigger. Let's go for 20. And we have our 20. And this is, as you can see, way too big. We can't really see anything else. And since we are in 2D plane, we can't really look around. But if we would have like make camera, then we would be able to look around, and we would be able to see that this object is just too big. We would be able to see that. We just need to make camera because this is already 3D plane. The image itself is just 2D, but aside from that, the plane is 3D and the object is also being rendered in 3D plane. So we don't need to do anything else aside from making camera and just moving around to see anything else, everything else. And we also need matrix for that, and matrix transform, and a lot of shit, a lot of matrices. That's it. But I'm not gonna do that right now because it's very difficult to understand right now, and turns out I can't really just understand by looking at it. It's gonna take time, and it's in like 2 chapters, and right now I'm only in transformation, and I need to finish this first so I can go to like 3D and then the camera. So right now we are only doing drawing 2D and seeing 2D in 3D. That's what we are doing by not specifying the z-axis. So this is one, we scaled it, and now I wanna downscale it 0.5. We wanna make a downscale it, so we wanna turn from 1.0 to 0.5. We have it smaller. I'm gonna do step by step to make it everything clear and very visually appealing, I guess. This is half, and now I'm gonna change the location from there to there, so it should cover this lower down right corner. It should cover the entire down right corner. Let's make it happen. So how should I do this? By changing the location. Here in the rotation, we're gonna rotate it on z axis, and here in the translate, we're gonna give in this vector the location of where it should be. It should be, it's in the center, so we want x-axis higher, 0.5, it's plus and minus. So 0.5 and minus 0.5, because y is in the negative. 0.5, 0.5. We don't really care about z-axis. You know what, let me just try specifying z-axis. I want to see what it does. Let's see what it does. And it does absolutely nothing, as I expected this thing to not do anything. Since this is a 2D not 3D, let's just make this thing to be 0. We don't get any unnecessary errors, and we have it in the lower right corner, and I want to make it rotate at I don't know, some angle. So in order to do that, we need to put this line of code in this loop to do it like every frame. So we activate shader here, we bind the texture here, and this is the texture, and this is just the uniform color, and draw the triangle here. I'm gonna do this before this part, and I think we did a good job. Transform here, and let's see how it does. And instead of 0, I'm gonna give like 5 degree, and it shouldn't really work, but I want to see if it works or not, and what it can do, what it does actually. And location is set, and I'm downscaling it, and I'm rotating on z axis, and this is gonna be a bit of a problematic, this part here, but let's see what happens. And as you may guessed, it's not changing, it just tilted a little bit, like 5 degree. That's it. The reason why it's happening is because the value itself is not changing, because in order to make it rotate, we use sine and cosine function, which gives a value between 0 and 1. So when we pass 5, it gives a value between 0 and 1, but when we constantly pass 5, we constantly get single values, because we are not changing the value. We constantly need to change the value, so we can get like a value between 0 and 1, not just one value between 0 and 1. So we can get like stream of values by doing that, and to do that we need to constantly like change the values. And the way to do it is, well, one way to do it would be increment this 5, like I don't know if I can do this or not, like plus plus. Oh, I cannot do that, my bad. We can have a variable over here and increment that variable right here. The way to do it would be, outside of the loop, have a float variable like this, and let's call it degree would be equal to 0.0 here, and all I'm gonna do is increment this degree. Where the degree? There is degree. I'm gonna increment it after this, uh, right here, degree plus. This is incrementing it, and let's see if it works or not. It theoretically should work, but let's see. We have an alternative and better solution to this, but as you can see, it does works, and we are incrementing it. So this one only changes like only 1 degree per frame. This one is only changing like 1 degree per frame. We can have it like even smaller than this by doing something like this. Plus equals 0.1, and this would be slower this way. 0.1 is way slower than 1.0, since when we increment it increments 1, but when we do this, as you can see, it's way slower. It's very slow. And to increase the speed, we can just do like plus equals to, plus equals 2.0. This is going to be twice as faster than 1. And you can see this is very fast, and we can make it even faster by doing 20.0. So this value must be changing in order to get this number. And since it's in a radian, this is beautiful, but there's a problem with this thing. As you can see, this is a float, and float is just 4 byte, and there's only so many numbers, and there's only a certain number of big numbers you can store in a float number 4 byte. You can only store some limited big number in 4 bytes. So, and we are doing nothing more than just constantly incrementing, so this is prone to give an error and crash our program. This is definitely gonna just crash our program, because well, there's no safety check. This variable is infinitely just getting bigger. We are not stopping it, we are constantly just incrementing it. So at some point it's going to break, because it will cause memory overflow, a stack overflow we call it. It will cause like stack overflow. Basically memory will be filled, and then we won't be able to run our program, because it just consumed all the memory over here. So it will crash our program this way. So one way to fix it would be to have like safety check, because we are passing this thing into a degree. So degree would be from 0 to 360 degree, and we can restrict it by doing if and else like this. If the set degree, if greater than equal to 360, then we're gonna degree set it to 0.08. So if the value gets higher than 360, then all we do is set this thing, and if it doesn't, then we just gonna increment it, right? We're gonna set it to, well, 0, and then we're gonna increment it with whatever we do. But we are not gonna do that. All we're gonna do is we increment it, and then we're gonna check if it's greater than or equal to 360 or not. If it is after incrementing, then we're gonna do this, set it, and then we just go back and do it again. Here we increment it and check it again. If it's again above 360, then we do this, otherwise we don't. So this will be kind of prevent it from going too high, as you can see. And for a particular representation, I'm gonna use degree. I'm gonna use this thing to basically constantly display this thing, and let's have it 20. This is gonna be filling up real fast. As you can see, 0 0 0 0 0 0 0 0. That means I'm resetting this value this many times. It's that fast. And we can display this outside as well over here. To, as you can see, It's gonna give from like 0 to 360 with a difference of each 20. As you can see, it's giving just that 360. After 360 it resets to 0. After 0 it goes 20, 40, 60 up to 360 and again 0. So this way we are effectively just restricting the value to stay under control so we don't crash our program. And this is one fix we can do, or we can do another fix which is theoretically supposed to be the better solution to this, alternative and better solution, which is, well, instead of having extra variable to it, we can pass the current time as an argument to the degree. That way we can have more of a precise, like, calculated degree. And the way to do that is dlfw get time, and we call this function. This function is gonna give us, well, time. As you can see, what it says is this function returns the current dlfw time in a second unless the time is being set using current time and blah blah blah. So we are not setting anything. We are just um, we're just calling this function, and I'm not sure why it's giving me error. Is it fine now? It shouldn't be. It should use this. Now it should be fine. Can I not use this thing inside it? Is that the problem? What is the error? Let me see it. What? No, instead of rotate match the argument list. Alright, well, I think I might need to use a variable in order to get this thing. I think I need to use a variable. And okay, maybe not. I think I can fix it. This thing accepts float as an input, so I just need to typecast this thing to float, and it should fix it, and it did fix it. It fixed it. GLFW, the current time we are passing it as a float, and let's see. This shouldn't cause any stack overflow since we are not storing this value. We are just directly getting the value and passing directly as an argument over here to get the value in radian, so we can rotate it. This is supposed to be theoretically more precise since it's doing like 1 degree thing. It's rotating at every 1 degree. So let's see. This is supposed to be more precise, and as you can see, it's rotating 1 degree at a time, and this is very slow. And we can do like multiply it with 2, add 1 or add 2. We can do that and speed it up, but as you can see, it works. And if it's too slow, then we can let go. Multiply it with 2, and instead of 1 we get like 2, and it should be twice as fast, and it is. So difference is 1, so we are only doing it like with 1 degree at a time. So if we add instead of multiplying, we add 1, we should have that. So from 1 to 2, if we add 2, we can have that. Right now, whatever value we will add, it will, or multiply, it wouldn't really make a difference. Adding and multiplying, the reason why it wouldn't is because the difference is just 1, so we are rotating it at every 1 degree. So 1 degree, whether you add 10 with 1 or multiply with 1, 10 will always be 1 regardless of multiplication or addition with 1, because it throws one output, that is 10. Because 1 plus 10, actually 1 plus 10 is 11, but 1 plus 10 is, well, 10. What I'm saying is it's relatively the same, not exact same, because addition always just gets 1 above, but it's relatively the same. So we can multiply it and get a bit slower. because this is 10 times faster. And apparently that's not how it works, I guess, because adding 10 to early made a difference. And I think that means value is not normalized between 0 and 1. What we are getting is a difference, not actually the value 1. It said it gives like every 1 second, so the function said it returns the time in second